Good afternoon, Block 3 and Block 4 physical science classes. It's Mr. Schmerchna. Hopefully, Mr. Weber's got you guys all settled in third block, and the sub got you guys all settled in for fourth block. At this point, you should have done your bell ringers. Just make sure we're learning to think on those bell ringers about what does that mixture look like? Are these things the same or are they different? This is how I used to do things sometimes during COVID and when I was gone. So I kind of needed our focus, and it was going to be tough to maybe do some of that. So, Mr. Weber's and the sub, feel free to pause this as needed, but everyone right now should have their packets out. Those of you who were gone yesterday, what we learned was that our last little part of this first unit is going to be in physical science. We start to understand the physical world, and what that really means is that we're going to start learning about matter and what the world's really made up of. So, everyone, yesterday we started page 25. So if you guys scroll through here, I'll be going to a different screen, but page 25 was what I call the pyramid of matter. So yesterday I thought we did a nice job in both classes, just starting to think about these particles and what things look like. But this is what will be, and I'll be coming back to this page in a minute here, but I'm going to go to a different copy because what we learned yesterday, everyone, is that matter, and this is where the sub and Mr. Weavers can pause it as needed, but matter is anything that has mass and takes up volume. One of the things we wrote as a class yesterday is that anything that has some type of density, that mass and that volume, even if it's not dense, like a little pocket of air, that is matter. So I think on your bell ringer we talked about how light is not, because you can't capture a piece of light and weigh it. So I'll have the sub kind of pause it when I say here, but really what we know is that matter itself as a whole, when I look at the particles of what it's made up of, it can either be considered what we call heterogeneous or heterogeneous, or homogeneous or homogeneous. So let's start on this left box together, and what I'll say is we could have the sub maybe pause it right now and you guys can write, and then as I talk you can listen. But when we first go to the left side and take that left side of matter and the fact that it can be heterogeneous, we know that what hetero as a prefix means is different. So these are, when we're going to look at those particles, these particles are going to have a very different appearance throughout. A lot of times you'll hear me use the word uniform. I always tell kids at Bergen, kids have to have a uniform. They all have to look the same. At Fremont, we do not have a uniform, which is why you're all allowed to wear your own different clothes. So that's exactly what you think it is from yesterday. I think it's important. We always have real life examples, but gravel. If I have a handful of gravel, a bunch of different kinds of minerals and rocks. If you mix oil and water, they are very different particles throughout. A bowl of soup, you got vegetables, chicken, broth, seasonings, all different throughout, and pizza's that same way. So I think you guys have a real good grasp on that, and we'll talk about what that really means in a minute here. We also know that matter can have the same idea to it. So when we talk about a homogeneous piece of matter, those particles, homo means same, they have a like appearance throughout. And what that means is that all those particles are going to have the same composition for the most part. So like I mentioned with Bergen, there is some uniformity and those particles are the same. When we say no particles suspended, there's nothing else just randomly floating in there. So we have to be careful with the way we think about this one, but air, if I just take a pocket of air from this part of the room and a pocket of air from this part of the room, if we're in the same room, those pockets of air are probably the same. If you take your blood, we have lots of stuff dissolved in our blood, but a droplet of blood from my left arm and a droplet of blood from my right arm should be pretty similar in the way that we think about that. Sugar water, although we know it's made of different things, if you really dissolve that sugar in water, you stir it up, you wait till it's all the way uniform, just like my cup of coffee here at 5:01 in the morning, if you dissolve it, it is all the same throughout. I mean, my first drink of coffee out of this cup and my last drink of coffee out of this cup should be the same exact thing. So what we have to do now is be able to think about that at a little higher level. So what we're going to go do here is let's think about in a homogeneous solution. We're first going to go and think about things that we know for certain. So if I go think about some things that I know are the same, what I know is that There are a large class of those things that are called a pure substance. And so we talked about this yesterday, but the word pure, I mean, if I told you my ring was pure, what I know is exactly what everything is in there. And what that really means in our class is that it's going to have a definite composition. What that means is if I go get the same ring in a bigger block, it's definitely composed of the same thing. It's always, no matter where I go get it, going to have that same components. Water from my sink here at my house is H2O. Water from the sink at school is H2O. And then it's going to have a formula. So that'll be the big thing. I know it's H2O, two H's and an O. I know the sink at school is two H's and an O, and that's why it's always made of the same thing. Now, we'll have the sub pause again in a minute, and I'll go back to those other boxes. But when we have a pure substance, something that is truly pure, it has its own name. It's not a mixture of things, and then it has that formula. It can either be an element or a compound. So sub should probably pause it here so you guys can write, but we learned yesterday that elements, and this is something you'll probably need to add on your notes, but elements are made of atoms. Iron is an element. Carbon is an element. Hydrogen is an element. We have a big periodic table of lots of elements. That's our next chapter, but an element is the simplest form of matter that cannot be separated by ordinary chemical means. What that means is once I get to a pile of gold, I can't get any smaller than just gold. It is the simplest form of matter. I can't get smaller than gold. There's not gold droplets. There's that element gold that's made of gold atoms. And you guys learned yesterday, this element will always only be that one capital letter. So it'd just be the capital H. Sometimes it'll have two letters in the symbol, like HE, but the H is always capital. The first letter is always capital, and that's how you know you're talking about an element. And again, make sure we have in our notes, this is made up of atoms. I told you guys yesterday in class, though, that I got a compound fracture in my freshman year. That's when we have two or more things. And what it is if I have those two things, like H2O, you should go write that example under here. Pure water is a really good example. You can't take that water and separate it by physical means. I can't physically go in with a pair of tweezers and take the H's and take the O's apart in water. However, chemically, if I think at a high level, I can go break those bonds, but that's much, much, much more advanced because it is a compound that's made up of two or more elements. And that's what you should go right underneath here. Two or more elements. And that's what we talked about yesterday. So capital N, lowercase a, capital C, lowercase l. That's the scientific formula for salt. So it has a formula. It has two elements in it for sodium chloride, which is why it's a compound. Water is a compound because it has two elements. Yesterday on your little project, sugar was C6H12O6. It had three elements, which is why it was a compound. So that's when we know that it's pure and it's always the same thing no matter what. We also know, though, that sometimes going back up here, we can have a homogeneous solution, which is the same, but we did that by mixing two things. So if you guys look, what's in between here, and the subcomposite in a minute, what's in between homogeneous and this bottom thing on the top is a solution, which we'll talk about in just a minute. But before we do that, let's make sure we go down from heterogeneous. If we have a heterogeneous thing like, again, gravel, oil, and water, the word we need to make sure we're aware of scientifically is the idea of what a mixture is. So let's pause it quick, and I'll actually scoot it up so you can write mixture and solution quick. But a mixture we talked about yesterday. We had all kinds of examples. We had the lemonade in class, but that's when we're talking about any matter that has had two things mixed together. But when we talk about a true mixture in science class, it can be separated by what we call physical means. So what that means, and let's write a few examples down here. Salt water is a good example. Gravel is a good example because you made those by mixing things. But the key difference is that you can separate them by physical means. When we say physical means, that means we're not going to go in and break the bonds because they're not bonded. If we have a bunch of sugar and water, they're not making something new. They're just in there together at a very small level. Physical means I can go undo it and get them back apart. So believe it or not, if I have sugar water, how can I separate that mixture back into just sugar and water? If If I put a pot of sugar water on the stove and boil away all the water, what would be left, class? I was going to say back of that room, block 3, we locked in. Mr. Weavers, is there any phones? Block 4, Braylon, you dominating back there? Otherwise, what that would leave everyone is sugar, and that means you separated it physically. Now, last but not least on this page, there's something called a homogeneous mixture, and this is like the salt water. This is where everyone, and feel free to pause it, this is where you've taken what's called a solute and dissolved it in a solvent to make a uniform mixture. And you'll notice I said a uniform mixture. You're taking those top 2 boxes, a uniform mixture. That's when it's going to be evenly mixed throughout. That's why. So an alloy. My ring is actually an alloy. It's a mixture of metals, but you can't tell. It looks really, really uniform throughout. That's called a solution, as is, even our blood. Our blood has a bunch of different things dissolved in it, but it's uniform throughout. So, with that being said, on your guys' copy, you have 2 other words at the bottom, and those are things. So maybe let's take a quick pause, and I'll bring this back in a minute. But when you guys are going to go start your labs in a little bit here, you're going to look at matter and you're going to separate it based on physical properties and chemical properties, which is something new I added on this notes page. So let's maybe take a 10-second stand and stretch and then unpause my video. All right, last little push here. So class, the other thing is when you're looking at matter that we want to be able to think about is it should have chemical properties and physical properties. In your lab in a little bit, you'll be separating the matter based on physical properties. And what physical properties are, feel free to pause it, but color, the length, the density, the volume, is it clear or not? Physical properties are things that we can look at and observe without changing the matter. I can look and say this metal is silver. I can look and say these purple rocks are big. I can look and say this would dissolve in water, and that's a little tough one, but all those things, I didn't change it. I just looked at it. I measured it. I didn't change it. Chemical properties, when we start to have a chemical reaction, you'll notice all of these things are undoable. You can't undo it. If I want to see how reactive something is, I have to burn it. If I want to see how flammable it is, I actually have to start it on fire. And you can't undo those things, which is why we call them chemical properties. Okay, so that's what should be at the bottom of your notes here. Now, Mr. Weavers and the sub will be in charge because there'll be a page in your packet you guys will do. But what you really need to get to today, and what I wanted to do with you, is just this quick separating a mixture lab. So if we need to, pause the video and make sure everyone gets their separating a mixture day 1 lab sheets, but maybe pause it quick because I did leave the purpose blank, everyone up here. There'll be 2 main things we're doing in lab. Once you've looked at that purple mixture, you're going to separate that mixture. We've talked about the word mixture based on its physical properties. Based on its physical properties. So you're not going to be allowed to change or burn or anything like that with the mixture. You got to separate it based on what it looks like. The other thing that you'll be looking at is the percent composition. So this will be a good example. Just the other day, the doctor told me Simi's blood, when she got tested if she was sick, 4% of her blood was white blood cells. With that being said, the percent composition is where you look specifically at the type of matter and what it's made of, not just randomly, but what specifically it is. So make sure we define what a heterogeneous mixture is, class. We should feel good about that. And then I did go through day by day here, step by step, and write out exactly what you should have. So today you should get all the way done, all the way to measuring out the first substance that you'll separate out based on physical properties. Make sure you check in with the sub, check in 4th block with Maggie or the sub if need be. Mr. Weavers will pop his head in probably, but otherwise, if you guys do get all done with everything, page 27 in your packet starts to talk about percent composition. You can look at that. Otherwise, I just wanted to make sure we had kind of some guidance on things. So if we need to rewind the video or anything, do that. Otherwise, please be on our best behavior for the sub. Think like scientists, and I'll be back tomorrow. Have a great rest of the day.